All right, we're in chapter 5 now on linear inequalities and linear programming. This is section 1, which is linear inequalities in two variables. So, in the previous chapter, we looked at graphing first degree equations such as y equals 2x minus 3 or 2x minus 3 equals 5. So, those are linear equations. Now, in this section, we graph first degree inequalities such as y is less than or equal to this or this is greater than 5. So, we're going to, instead of looking at equalities, we're looking at inequalities. Now, it's basically the same thing as graphing inequalities, but there's going to be something a little bit different. So first, we're going to discuss some important subsets of rectangular coordinate planes. So a line divides a plane into two regions that are called half planes. And so the graph over here shows a vertical line dividing it into the left half plane and the right half plane. So we've got, two pieces here. And the vertical line is the boundary line. So that big, thick blue line, that's going to be our boundary line. And so again, right plane, left plane, and then the boundary line. Now a non-vertical plane divides the plane into an upper and lower half with the dividing the line as a boundary line. So sometimes you're going to have, non-vertical lines. So you're going to have some kind of a angled line. And so we have an upper part that's up here in the upper half, and then we also have this lower half of the plane. And again, we still have the same boundary line. It's just we have an upper and a lower half. Now, what we want to do is find the half planes determined by the linear equation y minus x equals a minus 2. So first, we basically are going to plot y equals x minus 2 because we're going to take the x to the other side. And then when we do that, that's the boundary line we get. And so that's going to be when it equals. And when it equals, we're going to have that line as a solid line. And so anything above it is going to be greater than the x minus 2, and anything less than that is going to be less than the x minus 2. And so we can choose points like it shows here and see, if we have x is 4, y is going to be, up here in the upper half, and down here, when we do that, it's going to be down here. If we choose y, it's going to be down here, and it's going to be less than. So that's kind of what we're doing here. So if we, plug in those values, we can see where we're at. So this is kind of the gives example. If x is 4, y is 2, gives the point 4, 2. And so that's right on the boundary line. And if you were up above or below, that's going to give you something different. So what we can say now is the blue region is going to correspond to the inequality that's less than, and the kind of this tannish region is going to be the value that's going to be greater than. Okay. And this is kind of what it shows here. Just we're doing it one slide at a time. So this is going to be the values that are greater than the boundary line. Now, what we're going to do is for the linear equation, y equals x minus 2, we're going to replace that equality sign with either the greater than or equal to, less than, or less than or equal to. And so we get four different inequalities. And that means we're going to have four different kind of graphs for them because if you have the greater than or you have a less than, then you're going to have a dotted line. Whereas if you have the greater than or equal to or a less than or equal to, you're going to have a solid line. So the graph of each of these is the half plane, excluding the boundary line for the greater than or less than, and includes the boundary line for the greater than or equal to or less than or equal to, kind of like what I was saying there. And so, for the greater than, we have the dotted line, and it's going to be everything above. For the greater than or equal to, we have the boundary line. It includes it, so it's a solid line, and then everything above. Now, the less than, it's going to be a dotted line and everything below it, and less than or equal to is going to be a solid line and everything less than or equal to. All right, let's stop there, and then we'll come back for some more.